All right, so again, the media messages for girls a lot of times isn't about even the athlete being really good at what she does, but it's about her being pretty, or her, looking really nice, things like that. So girls aren't really encouraged as much as boys are to look to sports as a way to, do something cool with their life. Alright, so as we can see, this is a drawing done by a 10-year-old. I think this 10-year-old must be like freaking Pablo Picasso because this drawing's awesome. But much more detail when they're drawing at this age than they were when they were just making scribbles on a page at 2. Kids at this age play games, and they like to make rules. Makes them feel like, there's boundaries and they like that. So sports, they, are better at them because they do understand the rules. They understand like how baseball is supposed to be played, how soccer is supposed to be played, what are the rules to these games. But they'll also make up games. They'll make up all different kinds of hiding games and tag games and things like this that will have rules that, they all agree to follow. They're going to do still a lot of rough and tumble play, running into each other. Boys are going to do a little more than this than girls are, but girls do it as well. They'll also be better at video games, which does help with their hand-eye coordination. You just need to be a little more, just making sure that's not all they're doing all day, because again, we don't want to lead into that sedentary lifestyle. They're more likely to play adult organized sports, like being in a like football league, baseball league, things like that. Physical education at this time, usually in grade school, they're maybe getting 1 to 2 days of physical education, which is another reason why we're, seeing our kids that are not as healthy as they used to be. So with Piaget, we are now in his 3rd stage of cognitive development, which is the concrete operational stage. At this age, they do understand conservation. So they have decentration, which means they no longer centrate or focus on just one aspect of the problem. And they can do reversibility, meaning that they can understand that if, A equals B, well then B must also equal A. If I take the clay and make it into 4 different balls, I can take those 4 balls and make it back into one. Which if you remember from the video from our early childhood children, they're unable to do that. They get much better at classification. They're able to, make these really amazing hierarchies within their schemas to understand more complex ideas. So kids from 6 to 12, will really get into, certain things. Like they'll know a whole lot about dinosaurs or, baseball cards and things like this. And they know everything there is to know about it because they're really good at classifying the information. So as it comes in, they're good at assimilating and accommodating like as needed. So they get much, much better at this, which is good because their frontal lobes are going to start to be more and more myelinated as we move through this, which is going to help them, with the more complex tasks that they're needing to do at school. Their spatial reasoning gets better. Boys are going to be better at this than girls, and that's a true sex difference. We just see male brains are better with spatial reasoning, like reading directions, following maps, understanding like where they are in space than girls are. But both sexes will get better at this as they move through this age range. Our limits that we have here are that our kids at this age don't really understand abstract ideas. So their brain understands concrete information really well. If A equals B and B equals C, then A equals C. Great. That's concrete. It makes sense to them. When you throw something more abstract at them, their little brains just go into overload. This is why 2nd graders don't do algebra. You give 2nd graders an algebraic equation that's 5x plus 3 equals 18. They're going to freak out like, why is there an x there? What's going on? Because algebra is more of an abstract way of looking at numbers. It's not a concrete way. So we start with addition and subtraction and multiplication and division because those are all concrete ways of looking at numbers. And we don't get into our more abstract ways until we get into 6th, 7th, 8th grade. They're not really good with like metaphors. Those kind of just go over their head. They're not great with sarcasm. They don't really understand sarcasm very well yet because these are abstract things. Now, if you say to, a 6-year-old, 7-year-old, people in glass houses shouldn't throw stones, they will take it very literally and say, yes, that's true, because then the glass will break. They can't, think above this, that it means something else. There's a deeper meaning to it, the moral of the story. They're not quite there yet. They're going to move through this at a rate depending a lot on their IQ. Some kids move out of concrete operational thought and go into formal operational thought much earlier than other kids do, but a lot of it has to do with schooling. If you want to click on this video and watch it, you can. It just kind of shows how kids at this age cannot do a hypothetical situation. If you give them a hypothetical situation, they can only think logically about it. They can't think any other way. But an older child, by the age of 12, can think hypothetically and understand that there may be multiple answers to a single question. All right. Concrete operational thought, culture and schooling affect how well we can do on it. Going to school across the board helps children do better on Piagetian tasks because school helps you learn to think. But even non-school experiences can affect children. So, kids that are selling things on a street corner, have to learn, basic mathematics, even if they're not learning it in school. But it's still a concrete way of thinking about stuff. All right, so the Neo-Piagetians, so people came after Piaget, they're following along in Piaget's footsteps. They're still looking at assimilation, accommodation, trying to find an equilibrium, not liking it when our information doesn't, fit into a box that we already have created. Look at gains in information processing speed, saying that we get better at processing the information in front of us, that we don't necessarily move from concrete operational thought into formal operational thought. We don't just wake up one morning and, get metaphors. It's like, oh, now all, the jokes I didn't get before I do get. That it's more of a continuous thing and not a non-continuous step type theory. So when we look at how our information processing speed kind of helps this, they talk about automatic schemes or automatic schemas. And what this is when we have automaticity, it means that we free up working memory space because we don't need to use it because we know something so well. So if I say, it's 5 times 5, you all know 25. You didn't have to think about it. You didn't have to use any short-term memory capacity to know that. But if you were just learning your times tables, you would, it would take a little while to be like 5, 10, 15, 20, 25. That's using working memory capacity, short-term memory capacity. Automatic schemes free that up. It frees up working memory so that we can use our working memory to work on higher, more complex things. So that if I do get a big, long mathematical equation, in order for me to solve it, I have to break it down into smaller bits, but I know the answers to all those smaller bits, which are going to let me then do the great big equation. Oh, sorry. One more thing with automatic schemes is that it helps us with reading. So as we learn words, we learn them so well that we don't actually read the whole word, which is how all of you can read so much so quickly, and how all of you read so much faster than my second grader does, is because you know the words and your brain doesn't even read the whole words, it's automatized the words. So it's pretty much just saying, yeah, we know what this word is. You don't have to read the whole thing. And it's guessing. It's doing its best guess. So when you come to a word that you've never seen before, your brain kind of goes and stops and says, wait a minute, what is this? And you have to go back to using some short-term memory capacity. But when you're at college level, you're not using short-term or working memory to read. You're freeing up that capacity to understand what you're reading because you don't have to spend every moment trying to figure out what is this word, what is that word, because you've already automatized all of those words. Alright, so all of this stuff is going faster, so information processing speed and capacity just gets better because they're learning so much and they are having that automaticity and they're freeing up space. They also are having, different, as their brain's myelinating, as their frontal lobe is, parts of the limbic system, it's just making everything go quicker. Of course, this is also when we're more likely to see if a child, has dyslexia or ADHD, things like that, because their brain isn't doing the exact same thing that everyone else's is. And we can see it more as everyone else's information processing speed kind of speeds up and, this child's isn't. They also have gains in inhibition, so they are able to stop themselves from doing things, think it through for a minute and be like, oh, maybe this isn't the best decision, which we didn't really see in our 2 to 6 year olds. They don't really think out if it's a good idea to, take this glass and smash it on the floor. They're just going to do it. An 8-year-old shouldn't do it, and they know that. And so they're better at, stopping themselves from doing things that they know they probably shouldn't be doing. All right, so our attention in our 6 to 12-year-olds is way better. So our attention becomes more selective, adaptable, and planful. So a lot of this has to do with the reticular formation, which is what helps with attention. And as the reticular formation becomes more highly myelinated, it can just work better. And so since it's working better, we can pay better attention. So they're able to select what to pay attention to. I'm going to pay attention to my homework. I'm not going to pay attention to whatever's on TV right now. It becomes more adaptable. I can switch back and forth between things. So if I need to help you over here, I can focus on that, then I can come back over here and keep working on my homework. And then if my mom calls me, I can go and take care of that. So they can adapt their attention and go right back to what they were doing beforehand. And they get better at planning, like how much attention am I going to need to do this? If I have to sit down and do this homework, how much time should I allot to this? Our ability to plan is, pretty much mostly controlled in the prefrontal cortex, which is one of the last things to finish myelinating. So they're not great at planning yet, but they do get better at understanding how planning and attention go together. And obviously, as we move from 6 to 12, the 12-year-old is going to do this much better than the 6-year-old does. All right, so attention deficit hyperactivity disorder, ADHD. There's different types of ADHD, but across the board, what it's really looking at is it's an inability to pay attention and an inability to control impulsivity. And with that can come excessive motor activity. Children are more likely to be diagnosed with ADHD at this age range between 6 to 12, and it's usually when they start school that we start realizing that they're having trouble being able to focus or having trouble being able to control their impulses. ADHD is one of those disorders that is, very overdiagnosed, and it kind of goes in waves. We saw it being really overdiagnosed around, 2000s. Then it went down because we realized we were overdiagnosing it, and now it's going back up again. What's going on with ADHD is that the synapses in the brains are going too slow. So the connections aren't going as fast as they should. So a fast brain can pay attention. A fast brain is saying, pay attention, pay attention, pay attention, pay attention. A slower working brain is saying, pay attention, and look, there's something shiny over there. So because the brain isn't working as fast as it should, you're more easily distracted. And so one of the things we can do for ADHD is give the child a stimulant medication like Ritalin and Adderall. So stimulant medications are amphetamines. They're very chemically not very different from, a methamphetamine. But what it's doing is it's speeding up the central nervous system. So it's making everything go faster. So if your brain is going slower than it should, and you take an ADHD med, it speeds it up to the level that a quote-unquote normal brain would be working at. However, if we give a stimulant medication to a child who doesn't have ADHD or who has been, misdiagnosed or doesn't have a very severe form of it, then we're just, pretty much just giving them meth, and that's, not good. This is also why, people steal their little brothers and sisters' ADHD medicine, because it is an amphetamine. It gives them energy. It helps them to focus, just like it would if they, took methamphetamines or even, cocaine. It's doing the same exact thing to the brain. There's lots of other treatments for ADHD. we usually don't want to put them right onto a stimulant medication first. Diet, exercise, making sure the child actually does have ADHD, not just taking the word of your child's teacher or someone saying they have ADHD, but actually taking them to someone who has training in how to diagnose it, which means working with the family and the teachers and everyone involved with the child is the best route to go with us.